Hi, my name is Aaron Phillips, and this presentation is for the CS576 data mining class at the University of Idaho. I chose to do my term paper on concept, location, and legacy systems. Another way of putting this would be practical algorithm identification and location in legacy software systems. So here's a brief overview of what I'll be talking about. I'll give a brief description of the problem that my paper addresses, some previous work that has been done in this particular field of computer science, my solution to the problem, which I've called source code fingerprinting, the method and results of testing that I did, and finally some closing thoughts. I'm a software developer at a research laboratory, and one of the things I've had to do as part of my job is to reverse engineer a piece of software that we needed for one reason or another. Often this exercise centers around the challenge of locating a specific piece of functionality that you know is in the code. This is called concept location in the literature. It turns out that concept location is not just a reverse engineering task, but is actually central to many software maintenance processes. Often this comes in the form of one or more developers being tasked with upkeep on some archaic piece of code that they didn't even write. This usually involves finding parts of the code that correspond to the functionality that needs to be updated or repaired. To make matters worse, the code may not have external documentation, which leaves the developers doing all sorts of tricks like grep or manually debugging the code to locate the algorithms in the source code. There have been multiple attempts in the past to solve this problem, but they tend to rely on one or more assumptions about the source code. When these break down, concept location can become extremely difficult. For example, most solutions assume that the source code base is reasonably sized. This is less than 1 or 200,000 lines of code. They assume variables are helpfully named, and they assume, one, that there are in-code comments, and two, that they actually contain useful information. But like I said, these tend to break down in legacy software systems. Code bases tend to balloon over time, so 1 or 200,000 lines of code can quickly become 500,000 or a million lines of code over time. Best practices may not have been followed, and as a result, variable names might simply be X or temp or some other uninformative name. And the most frustrating one is probably the lack of helpful comments. There's quite a bit of work that has been done on this problem, and I'll just briefly cover a few of those here so you get an idea for where the state of the art is at. Biggerstaff was among the first to tackle this problem. He was also one of the first to combine both the formal and the informal information in the code. Informal being things like comments, variable names, things like that. Formal being function call graphs and data types, the actual structure of the code itself. He developed a user-driven tool which became common in the literature. This is basically a way to navigate the code using the information gleaned from the algorithm. So the user would see the results of some attempt to identify a concept in the code, and that might identify several other functions that the user hadn't seen before, and he would select one of those functions and the system would navigate there and select some more functions for the user, and so on and so forth. Chen did some work using abstract system dependence graph navigation. Again, this is similar to the work done by Biggerstaff with a user-driven tool focusing on, obviously, system dependence graphs. Kanellopoulos used C++ to come up with a set of attributes for objects, things like method names, member variables, things like that, and then use those as clustering entities and attempted to locate concepts using clustering. A few other solutions include mining source code revision history, an information retrieval approach, and various visualization tools. There's a 3D visualization tool for concept location out there. There's one tool integrates into the IDE, so it sort of maps out the software visually and then allows the developer to to navigate the code, similar to the user-driven tool from Biggerstaff, but in an IDE environment. So unfortunately, you saw that a lot of the previous work that has been done leverages both the informal and the formal information in the code. This is problematic in legacy code since the concept that you're interested in may not have any informal information, or it may be poor quality. For example, the comments in the code may just be documenting who changed something, or it may be just real terse revision history, things like that. You may not have a lot of descriptive terms that maybe help to identify algorithms in the code. You don't have things like objects, for example, in the C++ clustering algorithm. So it's difficult to get attributes to cluster on. And just the size of legacy code can often be a hindrance to things like the user-driven model that a lot of the literature focused on, where the user has to sort of navigate through multiple levels of function calls and things like that in a deeply nested call stack that can be really problematic and time-consuming. So to account for all of this, I came up with a system that leverages more of the formal structures in the code, specifically data types. My hypothesis was that parts of the code that implement the same concept will use the same data type, or data types. The idea of a document fingerprint was not mine. It's been in the literature for quite a while. Basically, it's an attempt to represent the information that you care about in the system in a much more compact way. So you don't keep all of the bits of a file, you just keep some representation that keeps as much of the information as possible. These source code fingerprints differ little from normal document fingerprints in that they contain only the data types used in a document and the frequency with which they occur. They don't keep any information of the order that the data types came in. So the system keeps track of where each type or each data type is in the source code and creates a database of fingerprints that can be easily searched. The overall system is fairly simple. There's a front end that allows the user to locate one file that hopefully implements the desired concept. I used a simple indexing scheme and keyword search, but since this isn't part of the main area of research, it could really be swapped out with any method in the literature that can quickly identify a single file out of the source code that implements the concept that you're looking for. Next, a fingerprint is created for that file and searched against the fingerprint database. This will create a ranked list of fingerprints that scored well against your query, and ideally they'll implement the same concept as the query. So the diagram you see here is the initial phase, the setup phase, where terms are extracted from the source code for the keyword search, and then an index is created for those, and then a fingerprint is created for every file in the source code, every source file, and the fingerprint database is created and an index into that database. So overall, the test results were a bit of a mixed bag. There were some encouraging results, but the system showed poor performance overall. I used the BLAST source code base for testing, which is a popular bioinformatics tool. It was written over a long period of time in C and has many of the characteristics of legacy code that I described before. There's over 1 million lines of code. There are thousands of functions. There are not many comments, and the comments that are there are mainly revision history, poorly named variables. I chose to search for 3 concepts that I knew were in BLAST using the system that I developed. I then evaluated the top 5 fingerprint database hits and looking for the hits to implement the same concept as the query. Most of the results did not implement the desired concept. Many results were tangentially related. They were either high-level drivers or they were adjacent to the algorithm it was being searched for. Um, BLAST is sort of a chain of heuristics, and most of the results had a couple of hits that were algorithms that were related to the algorithm that it was being searched for, but sort of next to it in the chain. And so you would see shared data types that would lead to false positives. Um, other problems were bookkeeping functions that again dealt with the same data types, and so the system yielded false positives there. There were some positive results, however. Several of the hits did implement the desired concept. One in particular was interesting from a software maintenance perspective. One of the files that was used to search the fingerprint database turned out to be a sort of ancestor from one of the hits in the database, meaning that the file was copied and pasted into another file and then added to. Um, this is really critical from a software maintenance perspective, since this sort of dead code is the kind of thing we'd like to eliminate. Over time, you see that these sorts of splits happen where code is duplicated, or another developer comes along and doesn't quite understand what the developer before him was doing, so he just sort of copies and pastes some of the code into his own section, and then sort of just quarantines the other code and leaves it around, just because he doesn't want to break the system by removing it. And so these are the kinds of things that in legacy systems you're looking to get rid of, just so you can have assurance that your code is working the way you think it is. So this isn't directly tied to the goal of the paper, but it was an interesting result. So to summarize, source code fingerprinting has potential as a concept location tool, but in its current state, it's largely ineffective. The system needs much more robust fingerprints, more than just the data types that were there. Global variables were left out, and a better fingerprint comparison technique needs to be implemented. So one that that takes better advantage of the information that's actually in the fingerprints, as to whether it's a return value or a parameter or a global variable or a local variable, things like that. And a more sophisticated database search method would also improve results. Thank you for your time.